Hi and welcome into another LeetCode challenge. Today we are dealing with merge sorted array, which is an easy problem. You are given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers, m and n, representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in a non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Alright, so we have example 1. Nums1 is 1, 2, 3, and those 0 discussed previously. M is 3 because only those 3 elements from the beginning. Nums2, 2, 5, 6, n is 3, and we want to do 1, 2, 2, 3, 5, 6. And here we have nums1, which is only 1, and nums2, which is 0, and output will be this array. Alright, let's think about it for a moment and get back to the solution. Alright, we are back in the LeetCode console. I will be using JavaScript, but you can use many other languages as well. So let me copy over one of the examples so we can have it as a comment here to discuss. And let's think what we would like to do. For sure, we would like to iterate over all the elements in the nums1 array. So let's instantiate ourselves a length of it. So const length, and it will be equal to m, which is the length of the nums1 array, plus n, which is the length of the nums2 array, and we will deduct -1 to account for the 0-based index. And now what we would like to do is to instantiate two pointers from the back. So to fill up those zeros, we will create a for loop which will go through for let I equal. It would start at this length, so at the end of this array it will be up to greater than or equal 0, and we will do I minus minus to go from the back. So we will be going this. Alright, and then what we would like to do, we will also compare from the back. So we will instantiate two pointers, one pointing at the end of the nums1 array and one pointing at the end of nums2 array. So let's do that. Let p1 equals m minus 1 and let p2 equal n minus 1. And then let's think about the conditions. So first of all, there was one example, second example in the problem, that the second array was blank. So if either second array will be blank or we will go through all of the elements from nums2 array, we will know that our job has ended, because if nums1 was already sorted as it should be, then there is nothing else to do. So the first condition will be that if p2 is less than 0, just break the loop and stop. It will be less than 0 because if the beginning array would have 0 elements, we are instantiating here a pointer at -1 to account for the 0-based index, then the p2 is -1, and the same would be here, that if we would exhaust the last element and deduct from it another place, it will be -1. So this is the first condition, and the second condition is if p1 is greater than or equal 0, because we need to know that we have some stuff to do also on the P1 level that we didn't add the P1 marker yet. And then conditional. So if nums at nums1 at P1 is greater than nums2 at P2, so we are comparing it. Let's say right now the P1 is here, P2 is here, and we are checking the value between 3 and 6. What is greater? If 1 is greater, 1 needs to be put it in the place. So if this is true, then we are doing nums at I equals nums1 at P1 in the nums1 at I, because we are doing it in place. And then we would need to deduct from P1. We can do it in this syntax. So after this operation finishes, that nums1 at P1 is taken, the P1 will be deducted. In the other example, other condition will be that either we are already at the end of P1, so we need to take all of the examples from nums2, or nums2 is greater than nums1. Then we are doing it the other way. So nums1 at I will take the nums2 at P2 minus value. So let's run the first suit. Let's see if we are good. Yeah, we are good on all 3 ones. And then let's try to go through this example before submitting. So first iteration and start of this is that the P1 is at 2, so it's here. P2 is also at 2, so it's here, and our current I is here, so it's at 5. And we are checking if 3 is greater than 6. No, it's not. So we are putting 6 here. This one goes away because we already did that, and we are changing the pointer. So pointer 1 becomes the same, P1 is being changed to 1, and I changes to 4. And now we are here and we are comparing. 3 is 3 greater than 5? No, it's not. So we are moving 5 here. We solved this element. We are going with P2 to 0 and with I to 3. Then we are checking yet again this 3 with this 2. Is it greater? No, it's not. So in this particular example, we are going 3 here and we used this element. And we have deduct from here and we are switching I. So right now we are with I on this element, with P1 on this element, and with P2 on this element. So we are checking. Is 2 greater than 2? No, it's not. It's equal. So we are moving this 2. We are putting it here. We are dropping P2 to -1, and we are dropping I to 1. And in this case, we will go in yet another iteration of the for loop, and we will hit this conditional that P2 is less than 0. So we are breaking, and our final result is this one. So I will do just a cleanup before submitting. And let's submit the whole suit. Yeah, and it works. So I hope that you learned something today, and see ya in another challenge.